Greetings, fellow grade 12s. It is Mr. Hlajari here. Welcome to Back to Basics. What we are doing today, we are looking at our inverse function, right? So basically, we are going to be looking at our exponential graph and also our logarithm graphs. Are we together, right? Please ensure that you've watched the first and the second video so that you can at least have much more detailed understanding of what an inverse is, right? But nonetheless, remember, we have our exponential function, right? Remember in the previous grades, when we discussed about an exponential function, we said this is basically where you're having y is equals to a to the power of x. Altogether, right? And then now we know that our a represents our, right? It represents our gradient. Function, right? So which means now, for an example, we are saying, let's say now when your gradient is greater than 1, right? So remember we had you know, the gradient where you're having your a where it's greater than 1, right? And we said now in this particular graph, right? When it's greater than 1, this is basically where you're having a graph that is going to be moving what? In this particular function. This is a function that will be moving almost this way, right? And we also have the what now? Our a, where now our a is also in between, right? Your a where it is in between what? Where it's in between -1 and also 1, right? And then now we are saying this is where now our line is going to probably be slanted in this particular position. Altogether, right? So now let's say for an example, I look at this just very two things, right? Now let's say I look at now let's say I have 2 to the power of x, right? Now how can you understand this one, right? So if let's say I want you to draw this particular function, this function will be what, right? If let's say this is my Cartesian plane, right? If this is my Cartesian plane, firstly, which means this particular function, it will be a function that will be moving in this way, right? And remember now, any number to the power of 0 will be 1, right? Which means this will be where you're having 0 and 1. And now, however, now, if let's say I am saying to you, now this is the function where you are having what? If let's say I say draw another function that will have what? That you are going to have your y, which is equals to now what? Where your y now is equals to 1 over 2 to the power of x, right? So this particular function now will look something like this, right? So this particular function now will be slanted in this position, right? Still intersected 1. Let me fix that, right? So it will again still be a smooth curve, right? This again would still be a smooth curve, right? Once again, and it will look something like this one, right? So basically now, these are just the two basic understanding of how will the shape of these two functions look like, right? But now, what we are going to be discussing today now, we are going to be discussing logarithms, right? I want you to just capture these two things that I've just drawn in here because they are going to form a greater part of our lessons as we are continuing, right? Right? If let's say you are given a function of, now this is same as your 2 to the power of x, right? 2 to the power of x. Now, you can also find the inverse of this particular function, right? And how do we find the equation of inverse, right? So remember to find the equation of inverse now that you have an exponential function, now it is going to be a completely different, right? So here, this is where now I am going to use, or this is where I am going to introduce to you the law of logs, right? Logs or logarithms, right? Now, how do you work with this, right? Now, according to the logarithm, right, we are saying if let's say you are having x, right, if you're having x is equals to a to the power of y, right? If let's say you're having x is equals to a to the power of y, right? Now to write the logarithm of this, the formula here now, what will happen? Remember where is your y? Can you see that your y is in your exponent, right? So if your y is in your exponent, remember you want to make your y to be the subject of the formula. So which means now this is going to be y is equals to log. Now this is going to be the base a, and also this is going to be x altogether, right? I know probably this formula might not make sense to you now, but let me just apply it practical now. Right? Let's see. Now, can you see that? Remember, we said when we are doing inverse here, now we are going to interchange, right? You are going to interchange your x and also your y, right? So which means this is going to be same as x is equals to 2 to the power of y. And now, how do you deal with this, right? So we are saying under inverse, we want to make the y to be the subject of the formula, right? So can you see that if your y is in your numerator here, now we are going to apply the law of logarithm, right? Where you are going to say now, look, your y is going to be equals to log, and now the base, right? This is log base, right? This is base altogether, right? And this is a constant, right? Log base constant, right? Altogether, which means now what is this going to be now? What was the base of your y? This was what the base of your y was 2, and then what is it that you had the value here? This is x. Altogether, so which means now this will be then the inverse of the what of the function, which is going to be log 2 to the power of what log base 2x. Once again, right? Let's maybe find more and more things, right? Let's say now I give you this. Let's say you are given that you're having y is equals to 3. This is to the power of x plus 1, right? And here we want you to find the inverse. Now, what is the first thing that you're going to do if you want to find the inverse here? Obviously, you're going to interchange, right? So, which means when you're interchanging, what is it that you're going to do now? You are going to change your x to be your y and your y to be your x, right? So, which means this is going to be x is equals to 3 to the power of y plus 1, right? And then now, law number 2, right? Now you are going to try and make your y to be the subject of the formula. And how are you going to do that? This is going to be same as what now? This is going to be same as x subtract 1, right? We are going to start by transposing this one here is equals to 3 to the power of y, right? And then now you are going to consider these as the base which we were having in there, right? So which means now from here, what is it then that you are going to have here? So can you see that this is going to be same as what? Now this is going to be same as y is equals to log. Now the base of your what? The base of your y, it is 3, right? So this is base 3, and then this is going to be x subtract 1. Can you see that one, right? So basically now this is going to be the inverse of this particular function, which is same as log. This is same as x subtract 1, right? Maybe let's get something else, right? Let's get something else. Let's say now we are given y is equals to 3 multiplied by 2 to the power of x. Now, what is it then that you're going to do here to find the log of this firstly, right? So can you see that you are going to start by obviously isolating this, right? Or interchanging first, right? Writing your x to be your y and your y to be your x, which means this is going to be same as what? X is equals to, this is 3 multiplied by 2 to the power of y, right? And then now we want to make the y to be the subject of the formula, which means you're going to obviously start by dividing by 3, right? And start by dividing by 3, which means this is x over 3 is equals to 2 to the power of y, right? And then now, what is it then that you're going to do now from here? Which means this is going to be y is equals to this is going to be same as log base. Now, what is the exponent or what is the base of y? It is 2. So this is base 2. And what is that you're having here? You're having x over what? This is x over 3. Are you together, right? So basically now this is what you are going to have here as the basic concept of this, right? Right? Let's say now I give you that you are having this, which is going to be your y uy is equals to log of, this is same as 3x. Now, I want you now to also find the inverse of this. Remember, this is not only the inverse, right? Remember, you can also still find the opposite using the same method, right? So, which means now we are going to be having this and operate backward, right? So, can you see that the base, what you had there as your base was what you had there as your base of your y, right? But now, what is the first thing that you need to do now from here? Even here, you start by interchanging your x and also your y, right? So what is it then that you're going to do? Which means this is x is equals to log. This is going to be same as 3 and also y. And now, how can you change this one now from here? Can you see now, if you want to make y the subject of the formula, can you see this is going to be y is equals what you had as your base here? This is 3. out again. And what is it that you had here as your constant? Now it's going to come at the top, right? Which is going to be x. Are you all fine, right? So which means now this is going to be y is equals to what? This is same as 3 to the power of x, right? Maybe let's get something else now, right? So let's say now here you're having y. This is y is equals to, this is same as log. So this is same as log of what? This is same as log of 2, and then this is same as x. This is x plus 2. Now, what is the first thing that you are going to do now from here, right? I want you to look at this carefully, right? So which means you are going to start by doing what? You are going to start by obviously interchanging your x and also your y. And how are you going to do that? This is going to be same as what? This is going to be same as your x is equals to, right, log, and then this is going to be log 2, then this is going to be same as y plus 2. Are we together, right? And now how are we then going to solve this one as we are continuing now? Remember, we want to isolate the y and make it to be the subject of the formula, right? And how are we then going to do that now in here? So then you are going to come back and say, look, now how are you going to do this? This is going to be same as what? Now I start by transposing the 2 this side. So this is same as x minus 2 is equals to, this is going to be same as log of what? Log base 2y. Out again. And now what is it then that you are going to have now from here? Now that you have this, can you see that now you are going to have y is equals to, this is same as 2 to the power of x minus 2. Out again. And which means this is going to be the exponential function which you are having in there. Y is equals to 2 to the power of x, right? And the first question, it says now that it wants you to write the equation. Let's say we are saying now you want you to write the equation of your inverse, right? Now, how can you write the inverse of this particular function, right? So which means you are going to say this is y, it's same as 2 to the power of what? 2 to the power of x. Then you interchange, which means x is same as what? 2 to the power of y, which means then now your y is going to be same as log what? Log base of 2 and also x, right? And now, if let's say we want to plot these types of functions, right? Now, these types of function will be plotted in what way, right? Let's say we want to plot these two functions, right? Now, remember, we want to either let your value of your x be equals to 0, right? If let's say you want to let your x to be equals to 0 so that you get your y-intercept, can you see that this is same as y is equals to 2 to the power of what? 2 to the power of 0, which this will be same as 1, right? So, and then now, can you see that your value of your a here is greater than 1, right? So, which means this particular function will be a function that moves in which way? This is a function that will be moving in this fashion, right? So this will be a function that moves in this way, where here you are having what? Where here you are having your, this is going to be same as 0 and also your 1, right? Now, the easiest thing that you can do now from here, if you want to draw the inverse, right? Now, let's say I am saying now draw the graph of y log 2 of x. Now, what is it then that you're going to do now from here? Let's see, for an example, what is the best thing that now you are going to do? Remember, we said an inverse is just the opposite of what you are having in here, right? So, which means now to find the opposite of this, right? To find the inverse function here, remember the coordinates that you're having here, it's 0 and 1. Once again, right? It is 0 and 1, which means now if you want to find out what will be the opposite of this, now, which means the inverse function now will be the opposite of what you are having. If here you are having 0 and 1, and then the inverse now will be what? Will be 1 and 0, right? And remember, we said for every time, if you want to draw an inverse, we must start with the line of what? Of y is equals to x, which means in this case, the line of y is equals to x will intersect somewhere here, right? Hopefully this line of mine, it is straight, right? And then now, can you see that the inverse now will be what? The inverse will have a coordinate here, which will be same as what? Which will be same as 1 and 0. I would get. Remember, we said inverse is the opposite. So which means if you have the point in the original function, you can just swap the coordinates and find the other point, right? So which means now this other function would now be look something like this. Okay, now where this is like this, right? So this other function now, it is going to look it's going to be something like this, where this is going to be the coordinate of this particular function, right? Where you're having 1 and 0, and then this other side you had what? 0 and 1. Altogether, right? So basically now that will be just the very, very basic understanding of this particular function. Are we fine? Let's say now we are looking at something else, right? So which means, and I want you to take note that the inverse of this function, where your a is greater than 0, if your a is greater than 0, if let's say this was my function, right? If the original function, it is like this, right? The inverse will always be like this. It will always be like this when your a is greater than 1. Why am I saying 0? Where your a is greater than 1, right? Unless there are other things that are added, right? But it will always be something like this. Now, let's say we look at something else here. Let's say now I give you another type of a function here, which we've discussed previously, which is the function of y is equals to 2 to the power of what? Y, right? This is same. Let's say I give you this is y is equals to same as, let's say this is same as 3 to the power of negative x. What is this, right? Now, can you see that this is same as y, it's same as what? This is same as 1 over 3 to the power of what? To the power of x. Altogether, remember this, I can write it this way, right? And can you see that 1 over 3, it lies, right? The a here, can you see that it lies in between -1 and also 1, right? So which means now, if let's say I had to draw this function, right? If let's say I had to draw this function, obviously I would firstly take the original, and then after taking the original, then I will come back to the inverse, right? So what will be the original of this function, right? If let's say I let my x to be equal to 0, this will be same as y is equals to 1 over 3. This is what? This is 0, right? And y at 0, this is same as 1. And which means now what will happen here, which means now this particular function would look something like this, right? Where it will go this route now. Altogether, where it will go this particular route. Let me try and write this much more nicer, right? So this will be something that will be a little bit curved, but it will look nicely like this. Yes, right? I think this is much more better, right? Now, and now what will this, now if let's say I say find out what will be the inverse of this, right? Remember how we find the inverse? We said this is, what this was y is equals to 3, or rather y is equals to 1 over 3, right? This is y is equals to 1 over 3 to the power of x. And then what will be the inverse of finding this? The inverse here will be same as what? Now the inverse here will be same as your x is equals to 1 over 3 to the power of y, right? And then now from here, what will then we do here from here? We want to make your y to be the subject of the formula, which means y is going to be same as log. Then whatever that is in the base of y, it's going to be base 1 over 3, and then this is same as x. Are we together? Now this will be the inverse. And how will this particular inverse look, right? So what was the original coordinates that we had here of this? Remember we said this is same as 1 and 0, right? If I'm not mistaken, this is 0 and 1, right? Which is what we calculated in here, right? So which means now if you want the coordinates of the inverse, if let's say in the original you had 1, 0 and 1, which means now in here you are going to have 1 and 0, right? And where is 1 and 0? Your 1 and 0 is going to be somewhere here, right? But before we write the inverse, we must always draw, right? We must always draw our line, right? And this particular line of ours, it's the line of y is equals to x, which is an inverse line, right? So which means we must always draw the line of y is equals to x. Can you all see that, right? So this will be something like this, and which means now if we draw this particular function of ours, where here you are having now 0, or rather 1 and also 0. Now, how is this function going to look like in this particular case? Now, this function in this case, now it's going to look something like this. It's going to come here, right? It's going to look at, it's going to be something like this. Are we fine, right? So basically now that will be this function. And I know probably my dotted line, probably it's not accurate, but then the dotted line needs to then move here, right? Needs to then cut where the 2 points intersect, or where the two graphs intersect. Okay, right? So which means my line, or my reflective line, will then be somewhere here, right? It will cut somewhere here. Are we all fine, right? But basically, when you are plotting this in a grid form, or rather in a grid sheet, you'll actually get this particular shape to be like this. Are we together, right? So I don't want to, drag this particular lesson so much. I just wanted to introduce to you what are logarithms, and how to move when you're having an exponential function, right? To find the inverse of the exponential, right? So thank you very much for listening.